Okay, so this is number 2 on the worksheet. It is a bonus. The reason I wanted to talk about this one is because I had somebody who was doing this problem and kept saying, like, I'm getting a totally wrong answer. I'm getting something, what was it, like 4,000 meters, something. And the answer says that it is V sub x equals 172 meters per second. There are multiple ways to skin this cat. What they're asking is, will the horizontal displacement with the maximum initial velocity at that height be more than 7.32 kilometers or 7,320 meters? You can solve this one of 2 ways. You can solve using that maximum velocity figure for the delta x. You can also use the 7,320 meters as your delta x and solve for the required initial velocity. So it's one of those things. These are, and as we move into more and more real world type problems, you'll find that there are more situations where if you read carefully what the problem's saying, especially if they're asking you to compare 2 things, you have multiple ways to approach that. And, I suppose if you were a real smarty pants, you could say something like yes or no. You got a 50-50 shot. Obviously on a test or a quiz, you have to have numbers to back that up. So you've got to have numerical evidence to say, no, it will not be greater than that at this initial velocity, or yes, it will. Does that make sense? Did anybody else have this issue? No? Okay, I'll shut up now. Okay, before we go to number 7, let's talk about number 3. So on number 3, they're asking you for the height of the cliff. If you find delta y, that's a problem with how the person who wrote down the answer key answer to that wrote it. The displacement of the ball is most certainly negative. The height of the cliff, therefore, is a positive number. So when I recorded that, I should have written delta y equals negative this, therefore cliff height equals, the positive of that. How far did you fall? 10 meters. How high was the roof? 10 meters. 1 is negative, 1 is positive. Does that make sense? So that was just my screw up. Okay, so we've got Bolivian basketball player Suleiman Nashnoush, 2.45. He throws a basketball horizontally from a level equal to the top of his head. If the speed of the basketball is 12.0 meters per second when it lands, what was the ball's initial speed? So what they are telling you, and if we could, I suppose, whoops, I erased his arm, get rid of Mr. Nashnoush, but it's so much fun to have him there. What we're saying is that this ball, does that. We don't know how far out it lands. So if we look at our x and y variables, the trick here is that velocity on the x-axis doesn't change. So let's examine that statement. Vix is what we're after, and that's the total Vi, because there was no initial velocity on the y-axis. So we know that VIY equals 0. A sub x equals 0. A sub y, negative 9.81 meters per second squared. Delta x, we don't know. Don't care. Delta y, we know, is negative 2.45 meters. And this is actually easier than it looks. I haven't done this problem in a year, so I'm coming to this cold, and I'm just trying to remember. Okay, so when we have this, that's a right angle. This is a trig function for which we do not have the opposite angle. So let's label a couple of things here. First of all, on that little blue triangle that I've drawn, that represents the final velocities that we've got. Oh, we're given final velocity. So this would be our final velocity on the x. This would be our final velocity on the y. We don't have an angle. We can't just use a simple trig function. I always forget this one, and it's always easier than I think it is. And once I see it, I'm like, oh, that's it. So we're puzzling through this together. So we're modeling this process here. Okay. What do we know? What do we know? What do we know? Let's go ahead, because we're interested in Vfx, which is equal to Vix, which is equal to Vi. Do we have any expressions that would link? Well, can we link here? Oh! Can we find Vfy? Yes. Okay, chapter 2, section F, free fall. Let's think about the motion of this object. Now I remember. What's its VIY? Zero. Do we know over what distance it accelerates on the y-axis? Yes. So do we know its VFY? Yes. Yes. We do. Because we know that Vf squared equals Vi squared plus 2a delta y. And we know that that is in fact 0. So Vfy squared equals 2a delta y. Now here's where we have to be careful. If we look at that little triangle that we've got, we would have an angle here, theta, which we don't know. And, oh, we don't need it. We could just use Pythagoras, to find, okay, hold on. Pausing again while I think. So let's make sure we have an expression for Vfy. So Vfy here would be the opposite side from that angle. Therefore, opposite hypotenuse. The sine of that angle theta would equal Vf over Vfy. Therefore, Vfy would equal sine theta Vf, and we're given Vf. We still don't have theta, but that may not be a deal breaker just yet. Okay, so then that means that, yeah, okay, as has been so ably pointed out by my dear friend. I had that upside down, sorry. Not the biggest mistake I've made all day. Okay. So we've got the expression Vfy equals sine theta Vf. Okay, let's plug that in and see where we get. Okay, are you all comfortable with the fact that Vfy squared is equal to Vf sine theta squared, which is equal to Vf squared sine squared theta? Okay, just distributing that step by step. I don't want to skip that because those become important. Okay, so then at that point, oh, wait, we have Vf, we have 2a, we have delta y, we can get theta. That's awesome. Do you see it? We can get a number and then take an inverse sine function. Okay, cool. Oh, this is pretty. I like this. Okay, so sine squared theta equals 2a delta y over VF squared. Take the square root of that whole shebang. That gets rid of that. So then inverse, I need new paper. I need to get rid of Mr. Suleiman. Or Nashnoosh, Mr. Nashnoosh. Okay. Let's get this over here. Okay, so theta equals the inverse sine function of the square root of 2a delta y over VF squared. Oh, well, once we have theta, guess what? We can just do a reverse trig function. Because now we have theta, we have VF, and we can use, that would be adjacent hypotenuse cosine. So cosine of theta to get us our VFX, which is equal to our VIX. Did that help?
Yeah.
Okay. Was it a little painful?
I'm confused why we use trig.
Because we have angles. And we're breaking apart the vectors at the end. So that final, are you confused because why isn't the final velocity just on one axis? Or?
Honestly, I don't know why we use
Okay. We'll sit down and run through it very slowly together.
Okay.
I'll do a little small group on this problem when people are ready for it, okay? Because I see literally it's about a 50-50 split where I've got about half of you going, okay, cool, got this, and half of you going, So we'll sit down as a small group on that later. Other questions you would like to look at? No? Okay, I'll shut up.